โอเคนะครับSo today we are going to talk about the application of double integral. So first is to find area, enclosure by curves. For this application, in fact, you can use a definite integral. Okay, to find it. Okay. You don't need to use a double integral at all. You can use just a single integral, okay, or definite integral. Let me give you the idea, which is if I have an area enclosure by this two function, okay, and it's from A to B, right? And you know that the definite integral, okay, is an area under the graph, right? And above the x-axis, okay? So for this definite integral, it's going to be the red shading area here, okay? Now, then you know that the green area, okay, is the area under this function. So it's going to be the definite integral from A to B of gx dx, okay? So this red, this green, okay? Then if you find the difference of these two, that means you find the difference of the area. So you get this area as a result, right? Okay. So this tells you that if you want to find the enclosure area, which is the blue one, you take the red area, which is the definite integral of your fx, okay, which is the function on top, and then you subtract by the green area, which is the definite integral of the lower function, okay? Then you get the blue area, okay? And by the property of the definite integral, you can take the integral out of the two terms, okay? So it becomes the definite integral from A to B of fx minus gx dx. See, you can use a single integral or a definite integral to find the area, the enclosure area, okay? And same idea, if you have a function this way, I would say it's not a function at all. It's a curve, okay? On this direction, say it is from C to D, okay? And if you want to find this, And you know that this is x equal to a function of y. And it is going to be another function of y. Okay? By similar idea, okay, you will have the area is equal to the whole area, okay, uh, of the right function, which is the definite integral from c to d of fy. Okay, this one you have the top and the bottom, right? You subtract each other. So this one you should have right and left, right? Because it's in this direction. So you have right and left instead of top and bottom. So you take the right function or the right curve minus the left curve, which is gy. And then everything with is respect to y, right? So you have dy here, okay? So in this case, you can use a single integral or definite integral to find the area, okay? But now let's see how can you use the double integral to find the area, okay? Uh, okay. So
อาจารย์คะ
ครับ
ช้าลงนิดนึงได้ไหมคะหนูจดไม่ทัน
อ้าวโอเคโทษทีโทษทีตรงนี้ได้ไหมเอ่ย
ได้อยู่ค่ะแป๊บนึงนะคะ
ได้ครับ อันนี้มาจากตัวแรกเนาะที่เราเรียนนะครับแคลหนึ่งนะครับ เลยเร่งสปีดนิดนึง
โอเคค่ะ
โอเคนะ now we are going to use double integral okay so this is the idea okay first if you remember the double integral over region R right is same picture which is there is a function of fxy that is represented by the surface in in three dimensions. Okay, and if you are interested on this region R, okay, now the outcome of this double integral is going to be the solid object, right? Uh, which is below the surface but above the region. So you have this solid object. Okay. Now, if we let your function to be a constant function and it's equal to 1, okay, let's see what happened. So your double integral becomes this, right? Okay. Now let's draw a picture, which is you have a function that is a constant function equal to 1. So fxy actually it means it's equal to z, right? So that means z is always equal to 1. And again, we are in three-dimensional space. So your equation is z equal to 1. X and y disappear. So that means it can be anything. So it's going to be, okay, from this, you can stretch along the x-axis, right, to be a line. And then since y disappear too, you can stretch this line. Okay? So actually it's the xy plane. And then you lift up 1 unit, right? Because it's the horizontal plane. Okay. Now, if you have the region R, okay. Now your surface is your horizontal plane, right? So when you do the integration, you're gonna have the solid object. That is, this height is always equal to 1, okay? Because this acts as the height, right, of the solid object at any particular x and y, okay? See at this x and y. If x and y is the height, okay? But this tell you that the height of this is equal to 1, right? All the way. I mean, all around the area, okay? So that means to compute the volume of this, again, you use this double integral over region R of the function, which is a constant 1, and dA, okay? But I'm going to use the advantage that this solid object has the height equal to 1 all around the area, okay? Then I can compute the volume, okay, in another way, which is, okay, the first way we can compute the volume by double integral, which is, uh, we have function, which is a constant 1 here, okay? The other way to compute this is going to be, I'm going to use the base area times the height, right? So another way to compute the volume is going to be the area times the height, which is equal to 1, right? Everywhere, okay? So I'm going to pair these two together. We have the integration over the region R of a function constant 1. It's equal to this too, which is R times 1 is going to be R. See? So you use double integral, and the outcome is going to be you get the region. Okay? And the way to get the region, you let the function here to be a function constant 1. Okay? And then the outcome will be, and it's equal to the region. Okay? So let me give you the example, which is, use double BOU, right? BLE, integral to find the area of region R enclosure by y equal x squared and y equal 2x, this n. okay? And y equal to 2x, okay? Let me draw a graph for you, which is you have a straight line, y equal to 2x, and then it's going to be parabola, which is, sorry, you should have over 2 here, okay? F over 2 here. So the parabola is y equal to x squared over 2, right? And the intersection point is 0, 0, and 4, 8. Okay. Now we need to find this area, enclosure by these two function or two curve. Okay. As I told you, see, the function telling you something that is in the form of y equal to, so it's good for a running number, okay? So you might want to integrate with respect to y first, okay? Now, I want to find this area, right? So I set this up, which is the area is equal to, I'm going to use double integral over this region, and then the function is going to be 1, okay? And there's dA, okay? Because I want to find the area. This is 1, okay? Now, then we are going to do the uh, same process, right? Well, I'm going to translate this. Since I decide to integrate with respect to y first, right? So I have dy dx, okay? Since I'm doing integration with respect to y first, your x is constant. So I'm going to fix any x, and then I'm going to draw the vertical line to intersect the area, right? So this particular x, which is x constant, you can see that your y running from this point to this point, okay? And this point is on this parabola, and your y equal to this, okay? And then y running to this point, which is on a point on the line, your y equal to 2x. So your running number for y is going to be from x squared over 2 to 2x, okay? And to find the running number for x, you need to ask yourself, this region sweep from which x to which x, okay? You can see that it's starting from this point, which is x equal to 0, and then sweep all the way, right, up to this x, which is x equal to 4, okay? So your running number for x is from 0 to 4, okay? Now, you can see that for this particular problems, okay, you can do the integration with respect to y, which is, it's going to be a good choice because the function is in the form of y equal to, right? It's good for the running number, okay? And another way to check is going to be if you look at from the graph, for any fixed x, it's in the same pattern, right? If you look at this fixed x, it's a point on parabola running to a point on the line, right? This fixed x, a point on parabola up to a point on the line. Okay, so you can do the integration with respect to y in this case. Now, you may ask if we can do the integration with respect to x first, right? So let's check, okay? Now, we can check from the picture, right? If you want to do the integration with respect to x, so your y is constant, then you draw the line, and it hit this point and this point, okay? And this line is where your y is constant, and x running from the point on the line to the point on the parabola, right? And this too, let's look at this particular fixed y. And the running number for x is from this point on the line to parabola, same thing, okay? And you can see that it's the same pattern here, which is a point on the line to a point on the parabola, okay? So you can do the integration with respect to x first too, okay? So in this case, let me pick this particular y, fixed y, okay? So the area is going to be, again, you use the function 1, right? And then you want to do the integration with respect to x first, and then with respect to y later, okay? Now, we are going to find the running number for x, right? Okay, we do the integration with respect to x first. Y is a constant, so we look at, let's say, look at this line for y fixed here, okay? And then the running number for x is from this point to this point, okay? Then there is a point on the line. We need to figure out what is x equal to. So you need to solve this function in terms of x, okay? Not in terms of x. Solve this function for x, okay? What is x equal to in terms of y? Sorry. So when you have this, you move 2 to the other side, right? So you have x equal to y over 2, okay? Instead of using this, you are going to use this. Now, for this point, again, you need to solve for x. What is x equal to? So you move 2 up here. So you have x squared equal to 2y. And solve for x. You have x equal to plus or minus 2y, right? Square root. But again, once you have this, you can see that for this parabola, your x is always positive. You don't have negative here on this side. You only have positive here. So you select the positive one only. Okay. So now we are ready, which is for this y fixed, x running from this point, which is a point on the line. So this point is x equal to y over 2. Okay, y over 2. Up to this point on the parabola, which we find out that x equal to square root 2y. Okay, so the running number for x is y over 2. to square root 2y. Okay, and you can see that for this region, if you want to find the running number for y, it should be a number here, right? You have to ask yourself, this region sweep from which y to which y? Okay, so it's starting from this level of y, which is 0, sweep all the way up to this level of y, which is 8, right? So the running number for y is going to be from 0 to 8. Okay. So I'll let you do the integration. Okay. Now let me ask you this one. I'll let you do by yourself, okay? Which is example. Use double integral. DI, okay? Double integral to find area an area of enclosed by y equal to 1 plus x squared and y equal to 2x squared. Okay, so let me draw the graph. Which is you have the narrower parabola. Actually, we have seen this problem before. And you have the wider parabola. Okay. This one is the narrower one is y equal to 2x squared. And the wider one here is y equal to 1 plus x squared. Okay. Intersection point is -1, 2, and 1, 2. Okay, now to find the area again, your function has to be 1, right? Now, let me ask you, which order of the variable, I mean, the order of integration, which variable you want to do the integration with respect to that variable first? เดี๋ยวเราจะจากรูปอะครับ จะอินทิเกรตขึ้นกับตัวแปรไหนก่อนดี
y ไหมคะ
y มีช้อยอื่นไหม ช้อยอื่นก็ x เนาะก็ดูแล้วน่าจะต้องเป็นแนวนี้ถูกไหมเนี่ยเพราะอะไรครับแพทเทิร์นเดียวกันหมดเลยใช่ไหมตัววิ่งจากพาราโบลากว้างไปแคบไปกว้างแคบไปกว้างแคบไปกว้างแคบไปกว้างเพราะฉะนั้นถ้าเรามองอย่างนี้แปลว่าอะไรครับ x คงที่เพราะฉะนั้นขึ้นกับตัวแปร y ถูกต้องนะครับควรจะต้องเลือกตัวนี้ dy dx นะครับ I'll let you try to find the running number for y and x in this case. Okay. Now if you look at the other way, y fixed, you can see that it's going to be harder because if you consider y is up here, you can see that things are, they are not the same pattern, right? Because this particular y is from the left side of the narrower parabola to the right side, left narrower parabola to the right side of itself. But over here is very complicated, which is left side of narrower parabola to the left side of the wider parabola, right side of the wider parabola to the right side of the narrower parabola. See? So they are not the same pattern of uh, compared to uh, the lower constant y below. Okay. So better use uh, integration with respect to y first. Okay. So I'll let you do this problem. Okay. Now, another application, okay, is going to be, let me use the same format. Use the integral, find area. Okay. Number 2, find the volume of solid object enclosure by surfaces. Okay. Let me give you the example. For this, actually, it's going to be the same thing that we did to find the volume for the solid object under the surface, okay, over the region R, which is double integral, okay? So let's see how can we apply that knowledge to this kind of problems, okay? Example is use double integral to find the volume, which is V, of a solid object enclosure by the plane 3x plus 2y plus OZ equal to 12 and xy xz yz plane. Okay. So ผมถามก่อนเช็คดูนะว่าเอ่อยังจำได้อยู่เปล่านะครับ อันนี้เป็นระนาบใช่ไหมการวาดระนาบมีอยู่2แบบใช่ไหมครับที่ผ่านจุดกำเนิดใช่ไหมกับไม่ผ่านจุดกำเนิดระนาบนี้วาดแบบไหนเอ่ยอันดับแรกผ่านจุดกำเนิดหรือไม่ผ่าน Is it passing through the origin or not? Remember? The answer is no, right? If it's passing through the origin, this number has to be 0. Okay. And since this plane doesn't pass through the origin, the way to plot it is you find the intersection of this plane to the 3 axes, okay, and form the triangle. Okay. Now let me draw a picture to you, which is this. You're gonna have the intersection on the z axis, y, x. The intersection to the z axis is, this one is 3. Now, remember, if you want to find the intersection to the z axis, your x and y has to be 0. X and y has to be 0. So you're left with 4z equal to 12. So divide by 4, you have z equal to 3. Okay, here. Okay. Similarly, you will have this to be 4 and this to be 6. Then you can form a triangle. Right? And when you know, uh, want to get the whole plane, you just stretch all the side of the triangle, right? Now, the solid object that this question talking about is, see, it's enclosure by this plane, x, z plane, zy plane, or yz plane, and then xy plane. So it's gonna be this thing. See? Okay. Now, if we want to use the double integral, okay? Now we try to apply the idea of double integral to find this volume, right? So this is going to be your region R, right? And your plane, use your plane here, which is the triangle that we find, is going to be the surface, right? And it's going to be on top of your region, okay? So it is going to be your z, is your function, which is actually this plane, okay? Then from this equation, I better solve for c so that is in this form, okay? So I'm going to move this 2 guy over here. So I have 4z equal to 12 minus 3x minus 2y. Okay. And then my z is equal to 12 minus 3x minus 2y over 4. Okay. So now I know my function already. Okay. Then to find this solid object, now the volume is going to be double integral over the region R. Okay. And my function is this. over 4. Okay. And then dA. Okay. Now, let's select the order, right? When you want to change dA to be dx dy or dy dx, we better look at the graph of your region R. Okay. So if you look at this, your region R, I mean enclosure by this line, right? And this line is the intersection of this plane to the xy plane, right? So to find the equation of this line, we look at the line, the plane, right? Since this line is the intersection of the plane to the xy plane, okay? Now, if you want to find the intersection to the xy plane, your z is equal to 0, right? This intersection happen when z equal to 0, right? Because it's on the xy plane. So you just plug in this c equal to 0 into the plane equation, this. So you are left with 3x plus 2y equal 12. Okay. Now, we can then plot or draw the region on the xy plane. X, Y. Okay. And you have on the x-axis, it is 4, right? On the y-axis, there is 6. And then you have the line that the line starting from this point to this point. This is your region R. Okay. And we already figure out that this line is in this equation, which is 3x plus 2y equal to 12. Okay. Now, okay, now we have the region, and then we can consider which order of double integral that we can do it with respect to that variable first, which is, well, if you look at any fixed x, you can see that the running number for y start from the point on x-axis to this line, point on the x-axis to this line, okay? And it's all the same pattern. That means you can do the integration with respect to y first, okay? Now, oh, now, in the other way, if you look at any fixed y, you can see that your x starting from this point, which is on the y-axis, to the point on the line, okay? Fixed y is your x start from the y-axis, point on the y-axis to the line. Same pattern again, okay? So you can use either way, okay? Now, since I already draw this fixed y, okay? Let me do the integration with respect to x first, so that I don't have to erase it, right? We can do it either way. So I'm gonna change this to 12 minus 3x minus 2y over 4. And I do integration with respect to x first, followed by y. Okay? And I need to find the running number, right? Which is for x, integration with respect to x first, I look at fixed y. Okay? And the x running from this point to this point, and we know that since this point is on the y-axis, x is 0. Okay? And it's run to this point, which is this point on this line, and it has this equation. I want to know what is x equal to, so I solve for x for this equation. So I move this to this side. So I have 3x equal to 12 minus 2y divided by 3, right? So I have x equal to 12 minus 2y over 3. Okay, so this point is 12 minus 2y over 3. Okay, so running number for x is from 0 to 12 minus 2y over 3. Okay, and you do integration following by the variable y. So you have to ask yourself, this region start from which y and sweep all the way to which y. Okay, so it's in the level of y equal to 0, sweep all the way up to the level of y equal to 6, right? So the running number of y is going to be 0 to 6. Okay, then you can do the integration, okay, for this. So it's going to be the similar idea that we use double integral to find the object under the surface over the region R, right? But we might need to, to do some change to the function, to the equation, okay? And you have to look at the region R, find all the information about region R. Then you can figure out the running number for each variable, okay? Now, let me find the information. Okay. Now, if you remember that double integral, we can do it in a rectangular coordinate system, which involve with variable x and y, right? And you can do it in polar coordinate. It's going to involve variable r and theta. And as I said that in polar, it is good for, I mean, if your region is in like a curve, like a circle, something like that. Okay. Now, next example is going to be, we're going to apply the double integral to find the solid object enclosure by some surfaces. And for this particular region, we might want to convert it to polar coordinate. Okay, let me give you example, which is use double integral to find the volume enclosure by x squared plus y squared equal 4. Okay. And z equal to 4 minus y. And z equal to 0. Okay. And this is actually when z equal to 0, x and y can be anything. Actually, this one is the xy plane. Right? Now, this is, if you remember, you have variable z and y, right? X disappear. This is a line on the YZ plane. Okay. And once your x disappear, x can be anything. So you stretch this line along, in the same direction as the x-axis. So this is the plane. Okay. Now, this one is a circle, right? 2 square. So the circle of radius 2 on the xy plane. Okay. But your z disappear. Hence, it's going to be a circle on the xy plane. And since z disappear, so you stretch, right? Along the z-axis. Okay. So it's going to be a cylinder. Okay. ทรงกระบอกใช่ไหมครับอันนี้ Now, so combine this four information together. Let me draw a graph for you. Which is you have something like this. Okay. This is x squared plus y squared equal 4. Okay. And then you have this. And the plane cut the cylinder. Okay, so this is a plane, part of the plane. And it cut the cylinder. Oop, like this. Okay, and you left with this surface. So this surface is going to be part of the plane. This is z equal to 4 minus y. Okay. And this is the solid object that you need to find. Okay. It's enclosure by the xy plane, right? So it's going to be above this. And enclosure by the cylinder. And it's enclosure by the plane. Okay. So there's going to be the solid object that you need to find. Okay. So from this information, that is going to be, this is your surface or your function for the integration. So V is equal to double integral over region R. Okay. And then this is your function of integration, dA. Okay. Now, you need to change this into dx dy or dy dx, or you might want to consider the polar coordinate system, right? Because your region is a circle. Okay. So it's going to be r, dr, d theta, right? So let's look at your region, okay, which is on the XY plane. There is a circle of radius r, radius 2. See? Okay. And since it's in a circle, I might want to change it into a polar coordinate system. Okay. So I change dA to be in polar. So you have r dr d theta. Okay. And then inside has to be in terms of variable r and theta too. But you know that y can be changed it into r sine theta, right? So inside it's going to become 4 minus r sine theta multiplied by r dr d theta. Okay. Then you are going to find the running number for r, right? So when you want to find the running number for r, you're looking at a fixed angle theta. So let me look at this angle theta. You can see that from this angle theta, you get a line, right? And the radius running from, or your r, running from this point to this point, which is from r equal to 0 to this r, which is on the circle of radius 2. So r is equal to 2. Okay? So running number for r is from 0 to 2. Now, to find the running number for theta, you have to ask yourself, did this region, your theta start from where and sweep all the way to which angle? So it starts from this angle, 0, and you can see that this region R, your angle sweep from 0, see, up to here, which is 2 pi. Okay, so your theta start from 0 up to 2 pi. Okay, so that is going to be the formula to find the volume in this case. Okay, so are there any questions? มีคำถามไหมเอ่ยตรงนี้ No? What we have left? Oh, we have about 40 minutes left. So let me start talking about, we have double integral. So this one is triple integral. Okay, integrate 3 ชั้นเนาะ Yeah. คราวนี้ let me give you an idea, okay? So let's look at a single integral, which is a definite integral, which is d(f(x) dx, and then double integral. Okay, over region R, right? Now you can see that I have a function of y equal to fx, which is one variable. And then I have the running number for x, which is from A to B. Okay. And the outcome of definite integral in one variable is going to be the area above the x-axis. Okay. And under the curve y equal to fx, okay, the outcome is an area. Okay. Now, for double integral, this one you have a curve, right? But this one, oh, sorry, should be x and y, right? This one, the dimension is going to increase one more. Instead of having a curve, you have a surface. Instead of having an interval, you have an area, right? And the outcome is going to be the solid object, okay, under the surface, okay. You can see that this outcome, you get an area which is in 2 dimensions. But the outcome for this double integral, you get the solid object in 3-dimensional, which is you are going to get the volume. Okay. And on the region R is on interval, right? From A to B. Okay. So you can guess an idea. Okay. Let me show you another way, which is for this, in order to get the area, you know that if we consider any particular x, okay, your dx, your fx, which is you take x, plug it in this function, you get the y value, which is the height, right? Okay, you have x, you want to know the height of this point on this graph, you plug this x in here, you get fx. So your fx act as a height, okay? Dx, well, for this x, I put dx here. So I can form a rectangle, right? Rectangle. Then dx times fx is an area of this small rectangle here. Okay. Now, since each x, I have this small rectangle, which has an area of this, I want to get everything from x equal to a or b, means I do the integration from x equal to a or b, to b, means for each x starting from a, I have a small rectangle, right? Which has the height fx and the length of this dx, and then combine them together, or I put them next to each other. See? Each x give me a small rectangle. So when I combine them together, actually I get the whole area, which is the outcome of this integration. Okay. Now, in the same way, if you remember for this double integral, okay, dA, I start with dx dy, for example. Okay. So any particular x and y, I can form a rectangle which this side to be dx, this to be dy, right? And then again, this acts as a height of it. Okay, so at this x and y, this is going to be your your height, which is f x and y. Okay, then in this case, I can form a pole. ไม่ค่อยตรงนะครับเนี่ยสามารถสร้างเสาขึ้นมาโดยที่พื้นล่างก็คืออะไรครับ2มิติเนาะก็คือ dx dy ก็คือบนพื้นที่นั่นเองนะครับเสร็จแล้วทำไมก็รวมตามแนวนี้จำได้เนาะเนี่ยตามแนวนี้ก่อนเมื่ออะไรครับ y คงที่ก็จะได้แถวของเสามาเนาะเนี่ยแถวของเสามาเนี่ยจนมาถึงข้างหน้านะเสร็จแล้วแต่ละ y คงที่ทำไมครับได้แผงเสามาอันนี้อินดิเกตเทียบกับ y ก็ให้ y วิ่งก็รวมแถวเสาทั้งหมดมันก็จะได้พื้นที่ไม่ใช่เป็นปริมาตรทั้งหมดออกมานั่นเองใต้ surface ตัวนี้นะครับเพราะฉะนั้นเราก็น่าจะได้ไอเดียละนะครับถ้าอินทิกรัล3ชั้นนะครับเห็นไหมตรงนี้บนช่วงตรงนี้บนพื้นที่เห็นไหมครับไออะไรนะมิติเพิ่มมาอีก1ละเห็นไหมครับจากช่วงเป็นพื้นที่เพราะฉะนั้นตรงนี้ต้องเป็นปริมาตรนะครับแล้วตรงนี้ก็ทำไมมี3ตัวแปรนะครับตรงนี้จาก dx เฉยๆ x ก็มิติเดียวเนาะความยาวเป็นปริมาตรเห็นไหมครับเป็นพื้นที่เพราะฉะนั้นตรงนี้ก็ต้องเป็น dv นะครับเนี่ยโอเคเนาะตรงนี้ผมขอใช้ในเมื่อมันเป็นปริมาตรนั่นแหละก็คือผมขอใช้คำว่าเป็นตัว s ละกัน s นี่ก็มาจาก solid เนาะ ก็คือเป็นเอ่อวัตถุทรงตันซึ่งก็ให้ปริมาตรนั่นแหละนะครับแล้วก็เป็นเทียบกับปริมาตรเล็กๆตรงนี้นะครับเพราะฉะนั้นเอ่อถ้าเรานึกถึงทำไมนะครับเนี่ยจากอินทิกรัล2ชั้นเนาะเห็นไหมครับมันเทียบกับอะไรครับเทียบกับพื้นผิวซึ่งเป็น2มิตินะครับแล้วก็เจ้า f(x,y) เนี่ยทำหน้าที่เป็นความสูงใช่ไหมครับเพราะฉะนั้นอินทิกรัล3ชั้นเนี่ยทำไมครับสิ่งที่เราจะอินทิกรัลแล้วก็บนตัวเนี้ยกลายเป็นวัตถุ3มิติถูกไหมเนี่ยตรงนี้เป็นวัตถุ3มิติไม่ใช่2มิติพื้นที่ละเป็น3มิติแล้วทำไมครับเจ้าตัวเนี้ยทำหน้าที่เป็นความสูงเพราะฉะนั้นสิ่งที่ได้ออกมาก็จะต้องเป็นวัตถุหรืออะไรครับ เป็นสิ่งที่อยู่ใน4มิติเออซึ่งเราวาดภาพไม่ได้นะครับเราจะวาดภาพออกมาไม่ได้เนาะใน4มิติสิ่งที่เราจะวาดได้เนี่ยก็คือใน3มิติเนี่ยถ้าเป็นในอินทิกรัล2ชั้นก็คือเราจะวาดได้แต่ตัว region ตัวนี้นั่นเองนะครับแต่ตรงเนี้ยใน4มิติอะเราจะวาดได้เพียงแค่ไอ้ที่อินทิกรัลเนี่ยมันอยู่บนไหนซึ่งมันเป็นใน3มิติเราวาดทั้งหมดไม่ได้ซึ่งเป็นใน4มิตินะครับโอเคเนาะตรงนี้งงไหมอันนี้ ถ้างงบอกได้นะครับ แต่คือจะพยายามให้เห็นภาพแต่ว่ามันวาดภาพไม่ได้เนาะเพราะว่ามันเป็นของใน4 มิตินะครับโอเคนะเพราะฉะนั้นอ่า then uh let me give you the property of triple integral first okay triple โอเค integral เหมือนเดิมนะครับ เราจะวาดภาพไม่ได้ แต่อย่างน้อยๆ เราวาดภาพที่ว่า integral เนี่ยมันขึ้นอยู่กับบน solid object ใน3 มิติได้ แต่เราจะวาดใน4 มิติไม่ได้เนาะโอเค so the first property is if you have triple integration or integral of a constant time of function which is f, x, y, and z dv. You can take a constant out of the triple integral. Okay. And also triple integral over the solid object S of f, x, y, z plus or minus a function of g, x, y, z. Okay. dv. Again, this is going to be similar to double integral, which is the triple integral can distribute inside, which is b plus or minus then triple integral g x y z dv. Okay, and now 3. Let's say that this triple integral it's on a solid object S. Okay, let's say your S has a shape like this. Uh, like this. Let's say the whole S you can think as a football. Okay. Now, what we can do is we can separate this S maybe into two smaller solid object, which let me call S1 and S2, where S1 intersect S2 is empty ก็คือเห็นไหมครับแบ่ง S เนี่ยออกมาเป็น S1 กับ S2 โดยที่ไม่มีส่วนที่ซ้ำกันนะครับนะครับก็คือแยกออกจากกันโดยสมบูรณ์นะครับ and S1 union S2 is equal to S แล้วก็เอาประกอบรวมกันเนี่ยก็ได้ S เหมือนเดิมนะครับ when you have this you can separate the triple integral by the region which is this f x y z of dv so you can have triple integral on S1 of f x y z dv and then plus Triple integral of S2. Like this. Okay. เหมือนเดิมนะครับ เราวาดทั้งหมดไม่ได้เพราะมันเป็น4มิติวาดได้แต่อินทิกรัลบนไหน ซึ่ง Triple Integral เนี่ยวัตถุที่อินทิกรัลบนนั้นเนี่ยก็คือเป็น solid object นะครับก็คือเป็นใน3มิติเนาะเนี่ยก็จะได้ประมาณนี้นะครับโอเคนะ okay, let me see this. Next, which is let me compare, okay, to the double integral, okay, which is integral. What we did with double integral, we can apply this similar idea to triple integral, okay? Uh, let me see. First, when I talk about double integral, remember, I start with the region that is simple, right? Which is the rectangle. Okay. Then you have a surface, right? Which is this. Corresponding to the region R. Okay. This your f x y. Z equal to Fy. And then if you remember, again, any particular x and y, okay, I form a small pieces of rectangle with this side is dx, dy, okay? And then there is the height. Again, this act as the height. So I get a pole. So right now I have see dA is coming from dx times dy. Okay. And this is this part here. See dx times dy. And this is the height, right? The height of this pole. Okay. And what did it do? If you do this is this pole, okay? And this is the base, which is a small rectangle, and this is the height. Now, when I do the integration with respect to x first, what is it? Y is fixed, right? So if this fixed y, okay, you include every pole, okay? X running from here to here. So you get a row of the pole. to the end. Okay. And then after that, if you do the integration with respect to y, once for each fixed y, you get a row of the pole. Now, if y running from here to here, you add all the row of the pole together, so you get the solid object or the volume, right? Up to the end. Okay, you add them all together, you get the volume underneath. Okay. And since I told you that when you have rectangular, I show you, so you can switch the order, right? And you have dy dx. Let's say x between a and b, so the running number is going to be from a to b. The running number for y, let's say from c to d. Okay, when you have a simple area like this, you can switch the order. So this you can have c to d and then a to b like this. Okay. Now, in case of triple integral, now you have to use your imagination, okay? Think along with me. Because we can only draw this, okay, that the integral is on this area in case of double integral. But in triple integral, the integration that on this is going to be on three-dimensional things. So we can only draw this, okay? So in case of triple integral, you can see that the simple case for double integral on the area is going to be the rectangle, okay? So let me draw this part of the triple integral, which is in three-dimensional. Let's use the simple case. In this case, we have, what is it? Rectangle for a simple area, right? So in the triple integral, the simple case is going to be this.ใช่ไหมเพราะฉะนั้นตัวภาพพื้นฐานของ2มิติก็คือ area เนี่ยก็คือสี่เหลี่ยมเพราะฉะนั้นภาพพื้นฐานของ3มิติก็ต้องเป็นเนี่ยครับรูปทรงสี่เหลี่ยมตัวนี้ไหมอ่าเพราะฉะนั้นถ้าเราลองนึกถึงนะครับคล้ายกันถ้าผมมองที่จุด x y z ใดๆปัญหาก็คือเรื่องภาพนะครับของเจ้า solid object ตัวนี้นี่นะผมพูดถึงอยู่ตรงนี้อยู่นะเนี่ยเพราะฉะนั้นตอนนี้มันมี3มิติใช่ไหมครับสิ่งที่ผมจะฟอร์มได้ตอนนี้ก็คืออะไรครับมันก็จะมีทั้งทางด้าน x เอ่อให้มันแนวตั้งแล้วกันเนาะผมจะมีด้าน x ด้าน y แล้วก็ด้าน z ละเห็นไหมครับตัวนี้นะซึ่งก็จะประกอบไปด้วย dx dy and dz เนาะนี่ตรงนี้เนี่ยตอนนี้เรายังอยู่ที่ฐานตรงนี้อยู่เนาะ เสร็จแล้วใน4มิติเห็นไหมครับฟังก์ชันตัวนี้ทำหน้าที่เป็นความสูงเนาะเนี่ยเพราะฉะนั้นอันนี้คือใน4มิติเนาะผมวาดเล่นๆแล้วกันเนี่ยมันก็จะมีไอ้เจ้าตัวเนี้ยคูณกับความสูงอ่าซึ่งก็คือตัวเลข W เท่ากับ f x y z เนี่ยนะครับเพราะฉะนั้นแต่ละส่วนก็จะไปจับกับความสูงเกิดเป็นคล้ายๆเสาตัวนี้ขึ้นมาจินตนาการแต่ตรงนี้เป็น3มิติใช่ไหมครับมีความสูงก็เป็นเสาขึ้นมาแล้วก็ทำไมอันดับแรกให้สมมติว่า y กับ z fix ผมก็รวมตลอดแนว x ให้ x เป็นตัววิ่งก็จะได้แถวของ x มาคราวนี้เสร็จปุ๊บอินทิเกรตเทียบกับ y ก็ให้ y เป็นตัววิ่งพอได้แถวของ x ก็รวมแถวออกมาตามแนว y เนี่ยก็จะได้เป็น3มิติ เสร็จแล้วพอได้3ชิ้น3มิติออกมาแล้ว ก็ต้องมารวมในแนว z เข้าไปอีกเนี่ยมันก็จะกลายเป็น4มิตินะครับโอเคเนาะเนี่ยไอเดียเนี่ยถ้าเทียบเคียงก็จะประมาณนี้นะครับเพราะฉะนั้นตัวพื้นฐานของ2มิติ the simple case for two-dimensional no double integral the area is going to be rectangle okay in three-dimensional it's going to be rectangular solid object like this okay and if you compare the idea okay so that means if you have triple integration with respect to the solid object f x y z dv okay your dv here okay when you have dA it becomes dx dy right dx dy or dy dx same thing but when you have dv you're gonna have dx dy dz okay that means okay, when change to this then you need to find the running number for x y and z now thing is going to be more complicated which is you can have dx dz dy see so which this two you get this then you can have f x y z now dy first dx dz then you can have dy dz dx okay you can have dz first and lastly you can have dz dy dx okay for double integral you have two order of variable that you want to I mean two kinds of integration depends on the order of variable but in triple integral you have 6 kinds of integral that you can choose depends on the order of variable นะครับเพราะฉะนั้นมันหลากหลายขึ้นมาทันทีเลยเห็นไหมมี6ตัวเลือกให้เลือกนะครับ and it's gonna be the same idea since there is a simple solid object right if you have this kind of object to be your solid object then you can change this form into any of 6 form here. Okay, and again, the running number for x, y, and z has to be number only in this case. And you can switch order right away. Okay, อันนี้มีคำถามไหมครับ อันนี้คือเราเทียบเคียงกับไอ้ double integral นะ กับเนี่ย triple integral นะครับ ตัวพื้นฐานมันก็คือตัวนี้นะครับ เพราะฉะนั้นเวลาเราจะแปลงจากตัวนี้มาสู่เนี่ยนะครับ ใน6รูปแบบนี้ ก็สามารถแปลงอันไหนก็ได้เนาะแล้วก็ทำไมครับ ตัววิ่งสำหรับ3ตัวนี้ก็ต้องเป็นตัวเลขเท่านั้นเนี่ยถ้าเราเทียบเคียงกับในกรณีของ Double Integral ที่พื้นที่เป็นสี่เหลี่ยมใช่ไหมครับ แล้วก็เป็นตัวเลข แล้วเราสามารถสลับลำดับการอินทิเกรตได้หมดเลยเนาะตัวนี้ ตรงนี้มีคำถามไหมนะครับ เพราะฉะนั้นเหลืออีก5นาทีนะครับ ผมขอยกตัวอย่างเนาะนำตัวอย่างก่อน so let's see this example which is find triple integration over the solid object S of the function x squared plus y squared plus z squared dv. Okay, when S is a rectangular box defined by S equal to set of x, y, z when x is between 0 and 1. Okay, and y is between 0 and 2. And z is between -1 and 1. Okay, yes. Okay. Then you can see that it already gives you an idea that S is a rectangular box, which is this kind. So it's the simple object. Okay. So see, running number for X is 0 to 1, for Y 0 to 2, Z is from -1 to 1. Okay. They are all number. So you can change this form into any of this 6 form. Okay. Let me choose the order as the example, which is, let me change it into x squared plus y squared plus z squared. And let me choose the order of dx first, dy, and then dz. Okay. Now, once I do this, I'm going to find the running number for x first, right? Which is from 0 to 1, followed by the running number for y, which is 0 to 2, and then followed by the running number for z, which is -1 to 1. Okay. So, let's try to solve it. Okay. Which is, we do the integration with respect to x first. These are constant. So you do integration with this, which is x squared. After you do integration, you get x cubed over 3. Okay, and these two are constant. There is a constant, so you have y squared x, or the antiderivative, right? So this one you have z squared x for your answer. Okay, so the running number is from 0 to 1 dy dz. Okay, so plug in 1 minus plug in 0 for x. So plug in 1, you have 1 over 3. Plug in 1, you have y squared. Plug in 1, you have z squared. And minus, plug in 0 for x, everything is 0. Okay, so you left with -1 to 1 dy dz. Okay, and integral with respect to y. So this is a constant. So you have this integral of 1/3 is of 1/3 y. Integral of this is y cubed over 3. This is a constant. So the integral of this with respect to y is c squared y. Okay, and the running number is from 0 to 2 dc. Right, and plug in 2. So you have 2/3 for y. Plug in 2 for y. 2 cubed is 8 for 3. Plug in 2 for y. It's going to be 2z squared. Okay, and then you minus plug in 0 for y. Everything is 0. Okay, so you're left with this. Then integral with respect to z. So this one you have, it is a constant, right? So integral is 2/3 times z plus 8/3 times z. And this one, integral with respect to z, you have to z cubed over 3, right? From -1 to 1, okay? So plug in 1 for z, you have 2/3, plug in 1, 8/3, plug in 1, q is 1, 2/3, plug in -1, minus plug in -1, -2/3, plug in -1, -8/3, plug in -1, become negative, right? -2/3. So if I take negative out, become plus, negative is gone, negative is gone, negative is gone. So I have 2 copy of this. So it's going to be 2 times. So they have the same denominator. So I add this together. So I get 12 over 3, which is 4, which is 8, right? Okay. So again, since there is a rectangular box, then you can switch the integral into any of this six integral. Okay, you can start by, let's say, dy first, dx dz, right? So any of order would be fine. Okay, and the outcome should be the same, which is 8. อ่าเพราะฉะนั้นเอ่อคาบต่อไปเราก็น่าจะคาดเดาได้เนาะว่าก็เปรียบเทียบกับอินทิกรัลสองชั้นก็คืออะไรครับจากวัตถุที่เป็นพื้นฐานเราก็จะพูดถึงวัตถุที่ไม่เป็นพื้นฐานเพราะฉะนั้นมันก็จะไปเกี่ยวข้องกับตัววิ่งละก็จะต้องเป็นกรณีทั่วไปนะครับอ่าพอเป็นกรณีทั่วไปเราก็มาคุยกันเรื่องของอะไรนะว่าเราจะหาตัววิ่งยังไงอะไรเงี้ยนะครับแล้วก็เอ่อบางเคสอินทิเกรตเทียบกับลำดับนี้ไม่ได้ก็ต้องเปลี่ยนลำดับนะครับตัววิ่งก็ต้องเปลี่ยนไปอะไรเงี้ยก็จะคล้ายๆกับ Double Integral นะครับแต่คราวนี้ปัญหาของ Triple Integral ก็อย่างที่บอกครับก็คือว่าเราไม่สามารถวาดภาพใน4มิติได้นะครับเราวาดภาพได้เพียงแค่เนี่ยถ้าเทียบกับ2มิติDouble Integral เนี่ยเราวาดภาพได้เฉพาะสิ่งที่ Integral เนี่ยมัน define บนตัวนี้นะครับเพราะฉะนั้นเราก็วาดได้แต่เนี่ยไอ้เจ้าตัว solid object เราวาดใน4มิติไม่ได้นะครับโอเคก็วันนี้น่าจะเท่านี้ก่อนมีคำถามไหมครับตรงนี้มีไหมเดี๋ยวยังไงวันนี้ช่วงค่ำๆเดี๋ยวผมจะให้กันบ้านอีก1กันบ้านเนาะไล่ๆทำก็ขออีกสัก2กันบ้านแล้วกันกันบ้านนี้แล้วก็กันบ้านถัดไปนะครับที่ต้องส่งเนาะเป็นคะแนนเก็บครับผม
อาจารย์คะ
ครับ
มีเฉลยกันบ้านเก่าๆไหมคะหนูไม่แน่ใจว่าหนูทำถูกไหมอะค่ะ
การบ้านเก่าๆเหรอเอางี้ได้ไหมเจาะจงเป็นข้อได้ไหมหรือว่าทั้งหมดเลย
ก็อยากได้ทั้งหมดอยู่นะคะ
อ๋อทั้งหมดเหรอเดี๋ยวผมดูอีกทีหนึ่งแล้วก็ถ้าไงเดี๋ยวผมไล่เขียนกันบ้านเขียนเฉลยให้เนาะ
ขอบคุณค่ะ
โอเคครับผมนอกนั้นมีคำถามอย่างอื่นไหมเอ่ยแต่วันนี้ผมรู้ตัวอาจจะอธิบายอะไรนะอินทิกรัล3 ชั้นอาจจะไม่ค่อยดีนะครับเพราะว่าเนื่องด้วยปัญหาอธิบายภาพด้วยเนาะมันใน4 มิติอะไรเงี้ยแต่เราลองไปเทียบเคียงกับ2 มิติดูดับเบิลอินทิกรัลดูนะครับไอเดียเดียวกันเพียงแต่เรามองไม่เห็นภาพเท่านั้นเองนะครับโอเคงั้นเจอกันวันพุธในห้องนะครับแล้วก็วันศุกร์ก็ต้องขอออนไลน์เนาะเพราะว่าผมจะขอพยายามเพิ่มชั่วโมงมานะครับแล้วอาจจะเจอออนไลน์อีกครั้งหนึ่งนอกเหนือจากตารางเดิมนะครับโอเคครับผมเจอกันวันพุธเนาะส
สวัสดีค่ะ
วัสดีครับสวัสดีครับ